I've been playing around with robots lately, and like most other hobbyists, I started out using standard PVM-controlled RC servos. And as usual, things escalated somewhat. I quickly realized that what I really wanted to build was more advanced and feature-rich robots than could be realized with your typical Arduino or PVM shields. I decided to build my own controller. My main requirements were the following. 1. Support for many servos, but without ending up with something that would fit in the cable porn subreddit. 2. Wireless connectivity. 3. Swarm capabilities, which again translates to thread support. 4. Sensor fusion. 5. Voice interaction. 6. Extensibility. 7. Easy programmability. 8. Dirt cheap hardware. Robot servos have some nice features. They allow you to record robot poses and moves, which later can be played back in code. They allow you to switch between joint or continuous rotation modes. They can be daisy-chained. This translates to reduced wiring harness complexity. They have onboard PID controllers and overload protection mechanisms. They have rich protocols which enable features you simply cannot implement with traditional RC servos. They also tend to be quite powerful. Even the smallest Dynamixels you see here have warnings in the datasheet that states may cause serious injury or death. So, what components do you need to build a decent controller? I chose an ESP32 variant for the main MCU in this project. This microcontroller has more than enough hardware resources to be able to process real-time sensor input and translate this into actuator control. It has lots of GPIO and also Wi-Fi and Bluetooth capabilities. Because I'm lazy, I decided to add one additional microcontroller. The reason being that I wasn't entirely sure if I would be able to implement everything on top of a single Bluetooth stack. I chose the NRF52840 because it supports both the OpenThread mesh networking stack and also allows for Alexa integration. I bolted on a BNO055 EMU. This is a 9-axis absolute orientation sensor that also does the sensor fusion bit for you. Using this, the controller can do 100 Hz active balancing. I also added an expansion port to the board. This exposes the I2C bus and 12 GPIO lines. The board runs on batteries. Battery power is fed unregulated through to the servo power bus. The battery voltage is also regulated down to 5 volts and 3.3 volts, since the servo data bus is in the 5 volt domain and the microcontrollers are operating in the 3.3 volt domain. You almost always have to do some form of plumbing in these types of projects. Components found in a drawer don't always play nice together, mostly because they operate in different voltage domains or don't speak the same protocols. Another example, in my case, is the need for a buffer or a line driver circuit to make it easier for the ESP to communicate with the servos over a half-duplex link. So this is the board layout. It's a 4x7 cm 4-layer board that costs about the same to build as you would expect to pay for an Arduino R3 sold at a Norwegian outlet. To the left is a list of the most interesting components in the design. So, we're feature complete. Let's see if it works.
Alexa, launch the robot overlord.
Welcome. You can say fire up the robot or you can say engage.
Help.
How can I best please you, Master?
Cancel.
What are you doing, Dave?
Alexa, launch Project Overlord.
Launching Project Overlord. Are you sure you want to do this?
Engage Dynamixels.
I wasn't able to get connected endpoints. You are an old fart that cannot code node. Your code sucks.
Alexa, launch Project Overlord.
Lucky you. Seems like you are a Lambda coding god after all. I found one endpoint.